Can you hear me? Okay, perfect.
Oh.
Okay, so there's a lot of you here. I wasn't expecting this big of an audience at this time, but we're really glad that you're here. We're going to talk today about some unique behaviors that we found exhibited by malware. A little bit. So first of all, my name is Marius. He's Ionuț, and a little bit about myself. I'm a threat hunter at CrowdStrike. I've been in the IT industry for over 7 years now, with the last 4 years focused on security at CrowdStrike and at Avira. I'm a food and travel enthusiast. I like food a lot. I know you can't tell, but still, I like it. I'm going to let my colleague introduce himself.
Does this work? Hello, so my name is Ioan Iacob, also known as Ionuț for my friends. I'm a threat analyst at CrowdStrike. I'm working in the IT security industry for 5 years now, previously with Avira. I consider myself a reverse engineer and digital forensic enthusiast. And I like to participate in CTF challenges. Speaking of CTF challenges, I invite you to participate on our challenge named Down the Rabbit Hole. You can go and talk to our colleague Ciprian about that and win our prize. So I'm going to let Marius do the first half of the presentation, please.
Yeah. We divided this presentation into 4 big topics. It's what we do on a daily basis. We're going to show you 3 what we found to be odd infection techniques. We're going to also show you some quirky but still legitimate behavior that we've seen. And we have 15 minutes at the end for questions and answers. So if you have any questions, just write them down and we'll have a 15-minute session at the end and we can discuss about those. Okay, so let's dive into what we do. So we do malware hunting, we do reverse engineering, and we write detections. We're actually 2 groups. The one I'm in is focused on malware hunting and on writing detections, and Ionuț over here is the one that does reverse engineering. So let's go into malware hunting. What does malware hunting mean? Well, for me, it's finding the unknown, basically. You have to find something that you've never seen before, something unique in behavior, something unique in the way it behaves on a computer. So how we do it? Well, we have multiple techniques that we use, workflows. First of all, we use Yara rules in Malquery. Malquery is a commercial product which is sold by CrowdStrike, and it's basically a search engine for binary files, right? It indexes all of the files, and then you can write Yara rules against it and find samples of interest if you want to analyze or find similar samples of something. We do use some Overwatch patterns also in Harrier. This is an internal system that we use. So these are very, very generic patterns. We're going to speak about them a little bit later in the presentation. Of course, we use VirusTotal. Who uses VirusTotal here? Okay, so a big chunk of you uses VirusTotal. This is our open source int feed, if I can put it like that. So we do VT queries to find interesting stuff in there. We also look for infection vectors, really important. Why? Because we need to find the kill chain as higher up in the tree as possible. And we also search for infections if we met customers, right? Now, hunting with Yara rules in Malquery. This is basically a simple Yara rule that I use to catch like interesting stuff. So for example, this one, it's a possible LNK link downloader. I'm looking for link files. I'm basically looking at the magic of the link file, and then I use the HTTP wide token. Why I use link file is because lately I've seen peak in the wild with link files that you do all kinds of crazy stuff, from crazy PowerShell one-liners, abusing Mishta, abusing WMI, and a lot of nasty things that are used with link files. And the funny thing about link, it's not funny, the bad thing about link files is you cannot give it a context, right? So if you think about the process tree that follows the execution of a link file, you will see Explorer that spawns whatever is on that link file, right? So you can give it context. You can give it context like when you have a PowerShell downloader in a WinWord, right? You see PowerShell under WinWord. That's easy, right? But when you have link files, the context, to give context to that execution it's pretty hard. So again, a possible link downloader, simple Yara rule, which returns, like in the last 2 weeks, 66 malware link files, 5 clean, and PUA. Okay, so this is like malquery. As I told you, it's an internal tool. Overwatch patterns. We use this also a lot, but they're mostly used for hunting targeted activity and sophisticated attacks. They're very generic. So for example, you can use a pattern that's just net use, right? Net use is like a legitimate command that is used by system administrator, right? But we've seen it used a lot by attackers in, like, if you want to move laterally or stuff like that. Another thing, another one could be WMIC and HTTP. We have an example actually with WMIC. Jonas is going to speak about it. This could be another pattern. It could, I mean, it's very generic again, and you can just block everything that uses WMIC and HTTP, right? What we found interesting though is that by correlating 3 or more of these patterns together, it gives us a good indicator that something's happening on that endpoint, on that machine, right? And somebody should take a look and investigate what's going on, right? So 3 or more patterns, that's basic. That means that something's wrong there. I was telling you also about VirusTotal, right? A lot of you use it. A lot of you, I don't know how you use it. I use it mostly to find new things that are running in the wild. So for example, in this query, I'm looking for emails. Luckily, I don't know if I could put it luckily or not, but it's luckily for us, we still see emails on VirusTotal for some reason, which is good for us. So we have emails, positives 3 or more. Why I use 3? It's arbitrary. It's just a number I chose to like exclude a lot of false positives, right? So if it's 3 or more positives for the email, then it's probably something wrong with that email, and I should probably take a look at it. I'm excluding some, I don't know, some CVEs, some vulnerabilities that I'm not interested in, and I get a list of hashes, right? With this list of hashes, I'm going to tell you at the end what I'm going to do with all of those hashes. Another example is this one, the query for zip files. I found, again, very interesting stuff using querying VT for zip files that contain these extensions, these file extensions. These are JavaScript, JScript encoded, VB script. I also use Windows script host, Windows script file. I also use LNK files over here to look to search, and I just download them all and make a small collection daily out of everything that I've showed you. So VirusTotal, malquery, and also from the Overwatch patterns, I take all of those hashes and detonate them. How I detonate them, I have a VM that has our product installed on it, and I get all of the information back. I get telemetry back from that VM. So after I find something interesting, like the needle in the haystack, I basically hand it over to my colleague over here, who does the reverse engineering part. And at the end, he's going to provide me with a report of what happened, what does that file do, and she's going to show you more. But that makes me feel like I'm his boss sometimes, because I give you something and you give me something back as a report. But who knows? Someday. Yeah, okay. So I'm going to hand it over to him for the reversing part.
Thank you, Marius, for the introduction. So when Marius finds new collections of files that he wants to analyze, he handles them to me or other guys from the team. So we started the reversing process on it. I'm not necessarily interested in what that malware does, whether it's a bot, whether it's a ransomware. I just care what it does in the system. Like if it's injecting processes, for example, injecting code in other processes, sorry. Basically, I look for events that are not seen in conventional tools. So one of them, as I said previously, is process injection. Another thing that we like to look for is malicious call stacks. remote procedure calls, VMI. I'm going to talk about VMI later for those that are not familiarized with this technology. Privilege escalation, credential dumping. There are a lot of tools out there in malware that want to do credential dumping and do lateral movement. Also, we look for some exploitation techniques. We have quite a few, but these are some of them: DEP, SLR, bypass, hip spraying, etc. And another step that can be done before or after the analysis, I look for other similar samples or other binaries, other PE files that are from the same family, so that I can be sure that my findings are correct and are accurate as possible. So I'm going to work with you through three different malware samples. I'm going to talk about their infection, how their infection works. Why is this not working? I'm sorry. So the first one is a malicious document that abuses MXIXEC to drop Delphi compiled malware onto the victim's machine. Also, this binary is digitally signed and the signature is still valid by today, which is a bit interesting. I'm going to talk about VMI and how it can be abused to inject a .NET binary into a legitimate Windows process. This technique over here is also known as Qibli2. You can Google that if you want to learn more about this. And then final example, and the most interesting from my point of view, it's an Excel spreadsheet that uses steganography to infect its victim. So let's dive into the first one, the malicious document that uses MXIXEC. This document was found in the wild. You can see a print screen of it in the right corner. It has by now industry standard social engineering message trying to convince the user that he has to enable the contents even though it's under a security warning, but who won't click that button? Everybody does. So let's see what it does. This is a screenshot from Falcon UI. We can see here the WinWord process, which opened that document. And we see that it created another process under it from app data local temp. And it has an interesting command line. The file name is table.exe and has a command line with a URL at the end. So what's with this URL over here? If you go and download the sample, calculate the hash and search it on VirusTotal, for example, you'll see that it's a Windows installer. Next. It's a Windows installer and has free detections on VirusTotal, which makes me think that it's malware, so let's look a bit into it, a little bit more. Looking into Process Explorer, the one from sysinternals, you'll see that after WinWord starts this table.exe, another two processes appear within the operating system. The first one is MXIXEC from the Windows operating system under services. And that one starts an SI host file. If you remember this MSI file that I talked previously, it has another PE file embedded within it. So if you unpack the code and drop the second stage sample, you'll end up with that Delphi binary that I said that it's signed. And the signature is still valid, and the detection ratio on VirusTotal increases each day. So let's look a bit at the interesting part of this infection scenario. I think I should go over here so that you can see the code better. If you open the Word document and extract the VBA script, you'll end up with this. From my point of view, it's a pretty small piece of code. The thing that's interesting over here, even though it's pretty small, it has also some junk code in it. You can see some variables over here, some objects being declared, but they're never used anywhere. So Looking through the code, I see this table.exe. And further down, I see file copy. And this file copy receives two arguments. The first one is frm.label1.tag, which it's a variable that I don't know where is it being declared, because it's nowhere over here. And the second one that holds the path to table.exe. The second instruction that catches my attention is this one down. So this basically concatenates two variables using that and then creates a new process. This creates a process with that command line, and we're going to see how that's being achieved. Looking more into the VBA script of the Word document, we'll see that it has an embedded win form in it, which is never being displayed for the user. It has multiple objects in it, the main window and some labels over here. So if you start debugging this script and go here at this file copy, you'll see that frm.label1.tag contains this path over here. The path to MSI-exec, which is a Windows binary, a legit 100% clean code from the operating system. And it's being used to copy it to table.exe. And of course, rename to table.exe. So where are these variables declared? These objects over here from WinForms have some controls. So if you look at the controls for each of these objects, down at the bottom you'll see a small property named tag. So that tag over there has the path to that URL that I told you, the one from the command line. So if you have a security product on your machine, or you want to do some forensics, or you have some cool script that automizes the analysis of Word document, of Office documents, most of them dump the VBA script, do some analysis over it. They can apply some YARA rules, they can look for strings, they can look for PowerShell encoded commands like base64, but apply some ML on it maybe, I don't know, or any other interesting technology that they may have, but you won't find anything here because all of the malicious part is being hidden in the controls of the WinForm. So I don't want to give you ideas because I know you have you are some pen testers over here, but instead of using MSI-exec, you can use PowerShell, and instead of having that URL over there, you can use an encoded command. And you won't see PowerShell being started by WinWord. You'll see a table.exe or whatever.exe with a very long string at the end, and not many red flags are raised because of that, but they should. So this was the first example. I'm going to go now to the next one. I'm going to talk about VMI and how it can be used to inject .NET into other binaries. The technique that I said that it's called Scribbly2. Also, some people like to talk about this technique and say that it's fileless malware, but it's not really fileless, and we're going to see why. This is a print screen from Falcon UI again. On the left here we see VMI. For those that don't know what VMI is, it's a technology embedded within the operating system, Windows operating system since Windows 95. It enables you to create SQL-like queries to the operating system. You can create files, you can create processes, you can delete registries, you can do whatever you want. It's a tool that it was and still is very popular among IT administrators, among network administrators, to be able to deploy different kind of scripts within their networks. But recently, malware developers started to understand this technology and to leverage its powers. So why is this VMI important? If you look over here on the right side, we have a command line which is being highlighted here. We see that VMI has a very interesting command line. Print or get device ID, format, then again a URL to some form/h forms. So what's about this this URL over here? VMI will go to this address, will download the contents, and if the contents are according to a standard, the standard is called extensible style sheet language, it will execute those instructions over there, whatever it finds over here. So let's see what's happening in that extensible style sheet. Sorry. So if you download the contents, you'll end up with this file over here. Think about extensible style sheet as a wrapper for JScript or VBS. In this case, the code, the programming language that is being used is VBS. So let's comment a bit about on the code. The first thing that catches my attention, it's this function over here, which is being collapsed not to occupy a lot of space on the screen. This, I think you already know, does some base64 decoding. Down, we see some declarations of some variables, and there you have assigned some different strings like exe, msbuild, a path to an interesting file named cversions.0.db, and Microsoft.NET Framework v4 and other numbers over here. Looking down into the code, we'll see that this function over here is being used to decode this very long string and assign it to the variable named frog. The contents of this variable are then dumped into a file on disk using create file and write line into these C versions over here. So this is the first file that touches the disk right now. And if you decode the long base64 string, you'll end up with some C# code. So what does this script do? It's creating a very long command line over here by concatenating these strings up top, and it's using msbuild to compile dynamically some C# code. That's the main reason why msbuild is over here, to compile C#. And then, of course, it's being run. Next. Yeah, this is the command line concatenated C Windows, Microsoft.NET, Framework v4, msbuild, and the path to that file over there. Next. Okay, this is the C# code. This is the main function, but you can't see it very well. It's a pretty short function. This is the code that will be compiled and executed by msbuild. So up top, we see, again, another base64 encoded string. Decoding that string will end up with a P binary. We can see the first 2 bytes over here, the MZ, and then the P header, which is being highlighted. And then several APIs are used to create a new process out of C Windows System32 ICS unattended.exe, which is a legitimate file within the operating system. It creates the process with a suspended flag, allocates some memory, writes some code into that newly created process, gets a handle to the thread, creates an asynchronous procedure call, and then resumes the thread's execution. By doing this, it's starting a new process, it empties it out, and then inject malicious code into it. So this is the entire functionality of this C# over here. But as I said, this is considered fileless, but it's not actually the case, because when msbuild over here starts the compilation, it will write a DLL onto the disk, into the temp directory with random name /.dll. And this DLL will be loaded and executed by msbuild. So this is why I'm saying that it's not true fileless infection story, because by now every forensic tool out there will be able to get this file over here. You can compute the hash, you can download it, save it to cloud, apply again some ML on it, do some static analysis or whatever. So it's not a very good idea to use MS-Build in this scenario, because you're not using the true fileless infection technique. So by now, since MS-Build compiled that C# and ran it, the previous file over here, which can be some backdoor, a bot, it can be a ransomware, is now running within your operating system as ICS unattended. So if you open up Task Manager, you won't find anything over there. You'll just see a file residing in System32, a process with a file path residing in System32. If you compute the hash of this file, you'll see that it's clean, but in fact it has running malware in it. So let's move on to the third and last example. Please work, okay. The one regarding steganography. Again, typical social engineering message with a macro on it. This one over here has a message in Italian, convincing you to click that button over there, and we'll see why the message is in Italian and not English or other language. In this case, I'm not interested in the VBA script. I'm just interested how it's being used to infect the machine. In this thread graph over here, how we like to call this nice picture over here, we see that Excel creates a cmd.exe process which spawns other processes, one cmd, another cmd, a clip.exe. Clip is the Windows tool that copies whatever you put on the command line, and it will be copied to the clipboard of the operating system. Then we see PowerShell being started, and we should have seen another process over here, but we're going to get in that details a bit later. So let's look at the command line over there. Next. This is it. It's pretty obfuscated. You can't read a lot of things out of this. But if you look closely, right in the middle, you'll see a URL string pointing to a randomly named image, randomly named file, which has a PNG extension. So at this point, I said, so why bothering to rename your executable as a PNG file? Of course, it's an executable. Let's download it and see what it does, and look at the file. Downloading the file and looking at the header, you'll see the magic bytes over here for the PNG file. So this is a 100% image file. And if you open it, you'll see a cute little green T over here. Tree, sorry. Okay. So what's the point of this? Why is it using a PNG file in the malware infection process? Going back to the code, this command line over here is being composed of two parts. The first one just echoes a very big string to clip.exe using this pipe over here. This copies the code to the clipboard, and then another PowerShell command is being ran. Let's look at this second part over here right now. This is the code, again, pretty bit obfuscated, but if we use some magic and deobfuscate it, we'll see that it creates a WinForm object, and using the clipboard class, it will invoke the getText method to get the content out of that clipboard of the operating system. And by doing that, it pipes out the content of the clipboard to invoke expression. Invoke expression, for those that don't know PowerShell, it's like eval from JavaScript. You just give it a string, and it will execute it happily. And the last line over here, just to remove the traces, clears up the clipboard, not for you to find any interesting garbage in it, for whatever reason. So let's go to the first part back again. This is the obfuscated code. If we add some new lines, the code will look something like this. And now it starts to make some sense. You can see some strings now. You can see some encoding over here, new object. You can see bitmap. You can see the link that we previously talked about. We can see a for loop. We can see even invoke expression over here, the shorthand notation. But it's pretty messed up. You can't understand the logic of this code. If you deobfuscate it a bit more, you'll end up with a pretty nice PowerShell script over here, and you can now understand what it's doing under the hood. So it's downloading the contents of this PNG file into an object of type bitmap. It then creates a buffer over here of 428 bytes. And using a for loop, it iterates through the first column of that PNG file, applies a mathematical operation on them, and decodes some data out of those pixels. So this is basically steganography, by embedding information into an image. So the math of this example is quite simple, I would say. You take the blue pixel, end it with 15. The result of this is being multiplied with 16. The green pixel is ended with 15, and the result of this is being ORed with the previous mathematical operation, and then all of this is being assigned to this output buffer over here. After that, this buffer is being converted to a string, and then is being executed by invoke expression. So by now, I expect that I'll have another PowerShell script that will be executed by our malware. So let's look at that as well. This is the last PowerShell that was in this infection routine or chain. We'll call it what you may like. We see up top URL to ipinfo.io/JSON. Downloading the contents of that file, you end up with a JSON that splits out information about your IP address, including your country over here. So we see an if statement, and it checks whether if you are from Italy. If you're not from Italy, you're safe. So it's good. If you're from Italy, then downloads another payload over here using the download file method, saves it to paint.exe, and there starts the process. At this point, I see, okay, someone went through the hassle of doing steganography and hiding its code as much as he can and doing some interesting things over here, but in the end, it downloads a PE file and writes it to the disk. Why do you do that? I don't know. But I think this is some sort of mistake that they didn't realize about that. And that's it. I'm going to handle the rest of the presentation back to Marius. Oh, I forgot about this slide. Yeah, this is the results of the AV engines on VirusTotal regarding that paint PE file over here. It had 6 detections when it was first seen, and then it rose to almost 40. So, please, Marius.
Thank you, man. Yeah, so about this last example, funny, it's not funny. The thing is that when we first saw this about 2 months ago, it was targeting Italy. We've seen it like a month ago, there was another wave that was targeting Japan. And then like a week ago, we found another wave that was targeting China. So they target countries, I don't know, one at a time probably. So yeah, that's interesting. Okay, so after I get the report from my colleague over here, we basically have to write detection rules. We need to, as I told you at the beginning, I don't know if you remember, we need to find a kill chain as soon as possible in the life of an infection, right? So even if we kill it like at the last stage, it's okay, but it would be a lot better if we could kill it later on in the life of the infection. So what I do is I basically write some detection rules by using multiple technologies that we have available in the product. These are strictly related to the product. I'm not going to go into details. I just enumerated some, like call stack analysis, process injection, remote procedure calls, process tree control. There's a lot of them that we can use to write detections. So what I did is I got a report from my colleague over here, and using some of those technologies, we wrote like 3 detections for each and one of them. So for the first 2, we used, for example, 1 and 3, we used IOAs. IOAs, we call them indicators of attack. They're basically indicators of some things that happened during that infection, into that process. It could be a command line, it could be a process injection, it could be multiple things, right? For the second example, we only used injection flags, process injection flags, and we got actually pretty good results with those detections. We saw malware, but we're also going to see like legitimate stuff that shouldn't happen, right? So I have a saying: just because you can doesn't mean you should. Just because you can use crazy PowerShell one-liner encoded, downloading stuff using crazy APIs, crazy functions, doesn't mean you actually should, because it creates basically a breach to your security, right? And there's a lot of people who do. I mean, it's their way of doing things. It's pretty hard to change this mentality, but as an industry standard, as a best practice, you shouldn't write a custom WinLogon into program data and then run it under SVC host and then spawn another WinLogon from there, right? So, but again, this was something custom made for them. It worked in their environment. We were looking and said, okay, it's good that you do this, but maybe you shouldn't. But after all, it's clean, right? This is another one that was actually really interesting. If you take a look over here, this is your typical, this is again a screenshot from Falcon UI. This is your typical phishing tree, right? So you receive an email, right, with some attachment, Win document that has some VBA script with it that launches some PowerShell command line, right? So this is your typical phishing tree that you see on a daily basis. If you download an email from VT today, now you'll find this phishing tree. But this was also a legitimate thing. They did this in their network, in their environment. This is the way that they did things. So we can't just go ahead and block everything and hope for the best. That's not the solution. We need to distinguish the bad from the good. The good thing is that we managed to distinguish the bad from the good, so we were able to fix this. Another one that I like very much is this one over here. Again, your typical phishing tree. You receive an email, you have an URL there, you click on your URL, Chrome opens up, you download a file that has this extension right here, pdf.zip.exe, which is which is pdf.zip.exe. But again, this was something legitimate. They were using some kind of encryption software that they used on files. So they sent files encrypted over the network via email to each other. So when they typed in the password, they could decrypt the file and look at the content of it, right? So again, I have to mention we can't go and block everything, right? Because there are people who do this, like this is normal business as usual for them. Even if it's abused by attackers, even if it's used by malware, it doesn't necessarily mean it's malicious in certain scenarios. Okay, so as some closing remarks, we've seen that, at least I've seen that productivity apps is still a big thing in the wild, and they're used as initial infection vectors. Why? Because it's really easy to bypass a spam email solution by just attaching a document, right? And then that document does some crazy stuff, and then you get access to someone's network. Quirky infection techniques are seen more and more often. Attackers use Windows legitimate binaries, as you've seen, they use MSI exec, they rename it. They use WMI, which is again legitimate and used by a lot of system administrators. Again, we can't just blacklist and hope for the best, right? And as my colleague said, adversaries do try to migrate to fileless infections, but at some point in this infection, they do drop some files on disk. So that's it for us. I think we have 5 minutes more for questions. I think we're out of time.
Sure, there's time. That's not a problem. Just a second. Anyone here near until there's a, yeah. And then the second row there, right?
First of all, thank you for the presentation. It was great. I was just wondering, because of the many bad pieces of code that are written for legitimate purposes, how do you decide, how soon do you decide that you're on a false positive track and that you should give up, or you just keep on investigating until your 100% is just bad code or bad practice?
Oh. Well, it's kind of hard because our product doesn't send data into the cloud. It only sends metadata. So when you have a file like the last one that I showed you, like this one over here, it's pretty hard to decide. But this one was actually kind of easy because we saw it was lying there on a shared drive, in some network, on the network, and we said, okay, this might be legitimate.
But you need more information.
Yes,
you need to
more
contact the customer.
Yes. Usually they contact us when they see something like this, like a false positive, and then they say, okay, this is false positive, so you have to fix it.
Okay,
right?
thank you.
You're welcome.
Thank you. We have a question in the second row here. Anyone else? Meanwhile, there, okay, there in the back, and then.
So I have two questions. The first one is, do you do any file-based detections or just behavior-based? I mean, just like an antivirus or just based on behavior solely?
The sensor has two components. It has the AV component, which is only machine learning based and looks at PE files. And then there's the behavioral component. So we also look at statically at files.
Okay. And the second question is, when you see oddities like these in your customer environment, it's actually two questions. Do you make suggestions that they shouldn't be using these types of?
Yes.
I mean, I assume they trigger a lot of alarms in your.
Yes, we do that. There are actually some sales engineers that take care of those customers, and we inform them, hey, they got this, maybe you should talk them into changing this. They don't always do it, but we try.
Yeah, the second thing is I wanted to know if you get any pushback on this. It's like,
yes.
I do this my own way and I don't care
yes.
about what your suggestions.
Yes,
okay.
yes.
That was it, thank you.
Yeah.
Thank you. And we have a question in the back. If it's still on, right? Perfect.
Okay, so it's.
In the first few slides, you specifically discussed about detection. I wonder if you made some profiling in order to figure out whether your model could be applied to real-time detection of larger throughput data.
We do that in the cloud. There are some plans of doing that for behaviors, but right now we don't. So we're planning on doing it. But it's not this model, it's not this ML model, it's a different one. This one only, I mean, the ML model, I think I got your question right. If not, stop me.
No.
So
it seems that it has a very good potential for application to real-time detection of...
It is. This is all real-time.
Yeah.
This is all detection and prevention real-time.
Yeah.
Yeah.
Okay, thanks.
Okay, you're welcome.
Thank you. Next in line is someone in the row in the middle, and we'll be taking after that one more question. So, one final question after this one here in the front row. Okay, thank you.
Hi, did you saw any campaign or of phishing, for example, with legitimate files only to get you into the wrong direction or something like this?
Not sure I understand. So legitimate files that...
Yes, like to send you a phishing to your clients, phishing emails, but actually the files inside to be legitimate.
Well, there is a
Just
funny
to-
thing.
And maybe next following an attack or something like this.
Funny thing, when I worked at Avira, a funny thing happened. There was a phishing campaign that was running in the wild, and somebody hacked the hackers C2, and instead of delivering malware, there was a JScript. The JScript actually delivered the AV antivirus, the Avira antivirus. And we were like, what? And he said, okay, that's good. And at that point, that was a pretty good thing for us. It was free marketing, free commercial for us.
Our last question here in the front row.
Hello.
Yes, Alex.
And
What do you want?
and for the non-PE files, for example, for Android and the Mac, do you have also behavior machines to watch over the
For Mac, you're talking about
for
Mac?
Mac applications and Android also?
For Mac,
Or-
we also have a ML model,
Okay.
which
We have
works.
several
Yeah,
models
yeah, for Mac.
different types
Also
of
have.
binaries,
And we also do behavior for Mac also. We
And
have a
also
sensor
for
for Mac.
Android, no?
Sorry?
including
And for Android?
Not yet.
Not yet.
It's probably in the workings. It's
pending.
going to be something really soon.
Okay, thank you.
You're welcome.
Yuan and Marius from CrowdStrike, thank you very much.
Yes, thank you, guys.